Okay, you know, let's do a little bit of probability. So far, you've been practicing putting your probabilities together into fractions and maybe timesing a couple of them together if you've got multiple outcomes happening. So you should be pretty familiar at this point with the idea that probabilities come in fractions or they come in decimals, and they kind of just tell you a chance of something happening. We take that one step further today, and we use probability to predict outcomes. So once we know the chance of something happening, we look at that event that keeps occurring over and over again, and we figure out how many times that thing should happen. We basically find it out so we can predict the future and make good decisions. It's something that's used commonly all the time. It's used a lot in sport. You look at the probability that certain players will shoot a goal or kick a goal or something like that, and that kind of tells you who should be playing up in the forward line. You know, the probability, you know, that they spoil someone kicking a goal, you put them in the back line, right? You make those predictions about what happens and what doesn't, lets you predict the future and make good decisions about what happens going forwards so you can get stuff right. Okay, so you should know by now what the probability is of an event occurring, right? We shouldn't have to teach you how to make these fractions anymore. You know, if I roll a 2 on a normal dice, there are 6 things that can happen, and one of them involves rolling a 2. You can also put that down as roundabout 0.16 or 17 roundabouts. Once we know these probabilities, we can then use those probabilities to predict how many times something should happen. All right, so a basic example of that is if I roll a die 6 times, how many 2s should I get? And in theory, right, if the probability works out perfectly, I'll be rolling the number 2 one time, right? I'll get each number on my die one time because they're all the same chance of happening. It probably won't work out that way because probability never plays out perfectly. But in theory, I should get 1, 2. And the maths behind that is basically, you know, I'm a 1 in 6 chance. When I do it 6 times, and I times those two things together, I get the answer being 1. Okay, so if you want the actual formula for it, I mean, it's not much of a formula. You might just want to write this down with everything else you've got in your glossary, in your probability section. If I want to predict outcomes, if I want to see how many times something should happen, I've got to find the probability of the event first. So you've got to do all the work you've practiced so far. And then you just get that probability and you multiply it by the number of experiments happening or the number of times you repeat the trial. So it could be the number of times I roll the dice, the number of times I have a shot at goal. That's essentially all you're doing. Probability times the number of experiments. We'll just do a couple of examples of this. Generally, these examples are all going to be real life things, actually looking at something that's happened and just turning what's happened into a probability fraction and a decimal. So we have a situation here where we have a hot dog factory that's very, very dirty. It's full of cockroaches and bugs and other things. And it's not even a very good hot dog factory. Every day they only make 67 hot dogs. That's all they can pump out in a day, right? So it's not a very profitable business, unfortunately. And to make it even worse, from those 67 hot dogs, at various stages during the day, 15 cockroaches will fall into the hot dog machine and get mixed into a hot dog. So this is a probability situation because you've got something happening and a probability within it. So we get asked a question, what is the chance that you've bought a hot dog with a cockroach in the middle of it? Well, all you have to do is take the two things that have happened, right? The hot dog factory made 67 of the things, and 15 of those 67 hot dogs might have a cockroach on the inside, right? 15 out of 67. Just to help our understanding, we'll turn that into a decimal as well. 15 divided by 67, or just using the fraction to decimal button on your calculator, would give us about 0.22. That means there's about a 22% chance that you have eaten a cockroach. And then we can apply either of these numbers to this predicting outcome situation, because we want to predict how many cockroaches will we eat. So there are 48 hot dogs that we've eaten, let's say in a year, maybe in a week, I don't know. They're pretty yummy. You just have to basically get your probability. So you can get your 15 out of 67. It's more accurate than using a rounded off decimal. And you just times that by the 48 hot dogs that you eat. The decimal version is fine as well. 0.22 times 48. Yeah, it's the probability that the thing happened, right? These are the probabilities, and we just multiply by the number of times we do the thing. So whether we multiply this way, whether we multiply that way, both answers come out at about 10.5. 0.7. We'll leave it at that. So for all intents and purposes, we've eaten about 11 cockroaches, which isn't so bad, really, considering how much fun we've had eating 48 hot dogs. Okay, so that's what we're doing. We're taking a situation, making probability out of the numbers involved, and then applying that probability to a number of experiments. All right, so if you want help getting started with your work, I've taken question 1, I've just adapted it a little bit and changed the names, changed the numbers. So not Natasha, we've got Nasha, the goal shooter in a T-ball team. In one season, she had 35 attempts at goal and she scored 2 goals, right? So she probably shouldn't be the goal shooter. Justin is the goal attack in the same T-ball team. Justin had 80 attempts and scored 18. So again, this team's not winning any games. We want to find the probability as a decimal of Nasha scoring a goal and of Justin scoring a goal. All right, so for Nasha, I would just say that it's 2 out of 35. All right, it's always good to start by making a fraction. And for Justin, slightly better chances. That's 18 out of 80. And then we just have to convert these fractions into decimals. Okay, so you can just go 2 divided by 35. That's fine. You can also type the fraction into your Casio calculator, push the S into D button, the fraction into decimal button. Either way, you'll get an answer at the other end. If we're doing it right, the first decimal answer would be 0.057. So it's only a 5 or 6% chance that our Nasha actually scores a goal. 18 out of 80 is slightly better, 0.225. That's 22.5% chance. You probably don't want either of these people playing goal shooter and goal attack. Who has a better probability of scoring a goal? Well, we just choose the bigger number. All right, so in this case, it's Justin. And then into today's work. All right, so you should be able to make your fractions, no worries. You've had a couple of lessons on that. But today's work is now extending on that. If they both had 40 attempts at goal in one game, what would be the expected team score? Because they're the only guys having a shot for goal. All right, so 0.057 is Nasha's chance. We times that by 40. We'll type it into our calculator in front of us. So 0.057 times 40 is 2.28 goals. So we're going to round that down to 2 when we finish our answer. But this is essentially all we're doing. The chance times by the number of experiments, we'll call it. And Justin's chance is the 0.225, also multiplied by 40. So we'll type that one in as well. 0.225 times 40 is 9. So we're basically getting 9 goals out of Justin, 2 goals, rounding down, out of Nasha. So for question C, the team had 80 attempts at goal, 40 here, 40 there, and they score 11 goals. They're probably going to lose. All right, so that's all you've got to do today. Keep practicing finding your probabilities, making the fractions, turn them into decimals as required, and then once you know how many experiments or how many repeated trials are happening, just multiply your probability times that number of trials, you'll get it right. All right, so only a few questions on your worksheet today, but then there's plenty on Mathletics for you to do to finish this lesson.